What's up, everyone? I'm Alon. I'm Alon. This is my backup dancer, Albert. Keep him up here to give me background noise. So I'm Alon. I'm from the Alchemy team. For those of you who have not heard of Alchemy, we're alchemy.com. And we're a developer platform for Web3 applications for the blockchain. My talk today is on building scalable, reliable, and data-consistent Web3 applications. So who am I? I am a developer advocate at Alchemy. I've been at Alchemy for almost 2 years now. So if you don't know what developer advocate is, we basically just make sure that whoever is building with Alchemy and building in Web3 is having a really good experience and advocate for all the developers building in the space. So whatever tools, products, features you're excited about or need, it's our job to make sure that that happens. I also started an organization called We3 that's focused on women and non-binary education in the space to make it more inclusive. And I started an ice cream company called Crypto Creamery that makes ice creams. Make ice cream on the weekends for fun. So building scalable, reliable, and data-consistent applications. I chose these words very specifically for a reason. And you might be wondering, like, why is this hard to do? Why is it hard to accomplish all of those things when you're building in Web3? And here's the problem. The blockchain is run by a network of nodes. And for those of you, most of you probably already know this. If you're not very technical, maybe this is still a little bit new. But the entire network is actually run by a bunch of nodes that are running software on their computers. Every node maintains a copy of the blockchain. So there's no like physical blockchain. It's just all of these nodes maintaining a copy of the state of the blockchain, right? And developers use these nodes to make requests. So any reads, any writes that you want to communicate with the chain has to go through a node endpoint. That means if I want to send a transaction, that goes through my node. If I want to read someone's balance from the blockchain, that goes through a node. So it's a really critical part of the developer infrastructure of building Web3 apps is this kind of node endpoint. And Ethereum was really designed for developers to be able to run nodes. Actually, like in an ideal world, all blockchain networks have individual developers running their own nodes. They run a piece of software on their computers, and they can connect and communicate with the blockchain. That is sort of how it was designed to make it as decentralized as possible, as accessible as possible, right? So you can just run a piece of software on your computer. And for a weekend hacker, for someone who's not sending a lot of requests, maybe I'm doing some MEV stuff, maybe I'm just kind of sending transactions here and there, that actually works okay. You'll still have to spend time syncing the node, right? Because nodes have to maintain the state of the blockchain, so you have to make sure it's up to date and sync all the previous history. You still have to maintain client updates, you still have to pay for the cost of running the node, and a bunch more other stuff that kind of happens under the hood. But generally, if you're not sending a lot of requests, you should be able to run your own node. That's kind of how Ethereum was designed. But what if you're someone like OpenSea? What if all of a sudden, in the past year, your traffic looks something like this? How would that work if you were running a singular node and you were no longer just a weekend developer sending requests here and there every so often? This is where we introduce problem number one of it being really hard to build Web3 apps, and that's scalability, right? If you're someone like OpenSea, what are the implications of running node infrastructure? Whoa. Not sure what just happened there. I think I clicked the skip ahead button.
Yeah, the button stuck or something, so we have to get to the very beginning.
You think it works now? Okay, sweet. Sorry, technical difficulty. So nodes can hold a certain threshold of requests. And this is pretty logical. I don't know if you guys ever use your computer and you're doing too much on it and the fan starts to overheat and then it shut down. Like, computers can only handle a certain threshold of requests before they start to fail. So if you get a huge spike in your usage, right? If you're doing an NFT drop, this is actually a screenshot from one of Alchemy's customers on the day of their NFT drop. This is what their traffic looked like. It was pretty steady, pretty slow, and then all of a sudden, they had a massive need to be able to handle an insane amount of traffic. So if you have this crazy spike and you're running your own node, it just won't work. It'll completely crash and burn, and all of a sudden, all these users that arrive to your application who are really excited about getting your NFT or using your product can no longer use it. What happens when a node goes down? Remember, it's a really important and critical part of the developer infrastructure of your application. So when a node goes down, your users can no longer make requests. They can no longer interact with your application anymore. And it makes your product virtually unusable. And that's because all information that goes to the blockchain has to run through this endpoint. So if it's not up and running, then you can't send information to the blockchain anymore. And you might be thinking, can't we just spin up more nodes, right? There's a very logical solution to scaling. It's like create more of it. When you create more of it, you can handle all of the requests. The problem there is that nodes actually can take weeks to sync. And one of our back-end engineers, Omar, is actually in the audience right now. He syncs Alchemy's node often, and he can tell you about how challenging it can be. So if your application crashes due to a large spike, and nodes can take weeks to sync, churn happens in seconds. I don't know if you guys are like this as users, but when an application isn't working for me, I completely close the application. I'll probably never return again. The same thing can happen with your Web3 application if it's not up and running. So you can't really spin up more nodes if you're in hot fire right now. And this introduces problem number 2, which is reliability. Your node reliability equals your product reliability. Remember, this is because it's such a sensitive part of your Web3 application's infrastructure. Even if a node is 95% reliable, right, which is like a pretty auspicious number, 95%, that's 1.5 days of downtime for your application. So an entire 36 hours every single month where your application is down if your node is just 95% reliable. Not only is that frustrating for your application, it's also frustrating for your engineers. Your engineers are now spending valuable time maintaining this back-end infrastructure and trying to upkeep this node endpoint instead of working on your actual product. They're just debugging. So maybe you get smart and you're like, all right, I know this is going to happen. I'm expecting a huge push. So I'm going to spin up a bunch of nodes ahead of time. Weeks ahead of time, I'm going to spin up all my nodes, and then I'm going to be ready for all the traffic that comes. This is where we get to problem number 3, data consistency. This is a little bit more of the trickier problem. It's kind of harder to get visibility into at first, and so we're going to look at it through an example. So why is data consistency really hard to do in Web3 applications? There's a logical scaling solution to reliability and scalability, and that's using what's called a load balancer. And for those of you who don't know what load balancers are, they're basically this in-between layer between your application and your nodes where you can funnel traffic to different endpoints. So if I'm getting a ton of traffic on my application and I know that one single node can't handle it all, I'll spin up a load balancer. When I get a request, I can funnel those requests to different node endpoints so that no single node can get overrun. This is super logical. It's a simple scaling solution. It's a very Web2 scaling solution. And in fact, a lot of node providers in the Web3 space use this to scale up, right? So they're running a bunch of node infrastructure under the hood. They slap a load balancer on top, and then that can funnel traffic to different endpoints. So it's super logical. What's the problem with this? Remember, blockchains are run by a network of nodes. And what implications do a network of nodes have on this data consistency issue? Well, every node, because it's run by a network, every node might have a different sense of what the latest block is. The way nodes communicate is, I'm a node, I have 10 peers, those nodes have 10 peers, those nodes have 10 peers, until we reach the whole network. And so if I find out about information, my peers and their peers might not also have that same information. And that's the implications of a network. That's how networks work. So depending on what node you're sending requests to, it might not actually have the same sense of what the latest block is because blockchains are run by this network. So this means that load balancing, right? So sending requests through a load balancer that funnel to different nodes can return inconsistent data. And this is where it gets a little bit tricky. So if I'm the green user and I ask for the latest block through my load balance node infrastructure, maybe I'll get block 102. At the same exact time, if I'm the red user and I ask at the same exact time for the latest block, maybe I get funneled to node 3, and they tell me the latest block is 101. This is the implications of using a simple load balancer. You might not get the same data because this is how blockchain networks function. Now, what does this mean for actual users, for your actual application? Let's walk through an example. So I'm a user. I buy a mutant ape, and I use a load balance node infrastructure to do this. And remember, load balancing is a very common solution in Web3. If you guys aren't using Alchemy, you might actually be using a load balance solution node provider or running your own nodes. So I buy a mutant ape. That gets funneled through the load balancer into node 2. So I get my mutant ape. The transaction's confirmed in block 102. I'm stoked. I'm happy. I have an awesome mutant ape, and I know it's in my wallet. Let's say I refresh my feed. I buy the mutant ape. I saw it there. I hit refresh button. Remember, all engagements with applications go through a node, right? Because you're querying from the blockchain. So even just a simple refresh on data, that read goes through. So I refresh my page. It goes through the load balancer. But this time, instead of getting funneled through node 2, it gets funneled through node 3. Now, node 3 in this load balance infrastructure isn't yet aware of block 102. And what that means is my purchase of that mutant ape is now gone. Not because it's actually gone, right? It lives in block 102, but the node I'm communicating with isn't aware of block 102, which means my application is telling me, hey, you don't have your mutant ape. I know we said you just bought it, but now it's not there anymore because we're not aware that that existed. So this is where data consistency is extremely important. And it's often overlooked in a lot of Web3 applications and a lot of node infrastructure platforms. So what do? I've been yamming about how hard this thing is and all the challenges that you face when running node infrastructure in Web3. So what can you actually do? Well, there's a simple solution to this. You build out a higher level infrastructure engine. This is what it looks like for you. You have one endpoint, and it's done. You don't have to worry about data consistency. You don't have to worry about scaling. You don't have to worry about reliability. That's it. This is all you have to use in order to make this happen. This is what's actually happening under the hood. And this is our kind of high-level infrastructure diagram for what we've built out at Alchemy. So we spent the past 2-3 years, 2-3 years ago, we've been live for about a year and a half now. But we spent the first 2 or 3 years just kind of in stealth mode building this out. Really thinking about what are the extremely challenging problems that come with running node infrastructure in Web3 and coming up with this higher level infrastructure engine that solves for these issues. So no, it's not actually really easy under the hood. It's really easy for you because all you have to do is spin up a free account and just get access to this endpoint. And it gets funneled through this larger infrastructure engine that we spent years and years building, refining, and mastering, and are continuing to iterate on to find those niche issues. So what are the key components of this? There's a coordinator service that kind of helps funnel different requests. There's a consensus mechanism that we built. And remember, this is all on top of the node. So yes, blockchains and nodes all have these things too. We built out our own versions of this that sits on top to make sure you don't hit any of these issues. There's a consistency layer. We use diversified node clients. So I don't know if many of you know, but there's a bunch of different node clients out there. And if you're just running one and that one has a bug in it, then you can no longer actually serve requests and engage with the blockchain. So we make sure to run a diversified set of node clients. We index a bunch of data stores. We also provide a caching layer so that requests are served to you a lot faster than they otherwise would be. What does this mean for you? How does this implications for the end user? You get consistent data. You don't have to worry about users experiencing changes in their mutant ape purchases or their NFT purchases. You have instant scalability. So if you are OpenSea, we do power all of OpenSea. So if you are OpenSea and you have this insane spike, we don't have to worry about upscaling your nodes and running a bunch kind of instantly. You have increased reliability. We also have a bunch of enhanced APIs built on top of the platform to make indexing things a lot easier. And free archive data, of course. So if you don't want to spend $200 on archive data, it's completely free on the platform. At a high level, we've developed a proprietary distributed blockchain engine that provides infrastructure and solves for these 3 really challenging issues: scalability, data consistency, and reliability. Our platform has a bunch of other tools for developers as well. We're built on a bunch of different chains. But really, the bread and butter here is this supernode, this infrastructure engine that I've been talking about this whole time. Other products that we offer for devs are Alchemy Build, Monitor, and those are both debugging interfaces like dashboards and more insights into your requests. We have a notification system, so if you want to get notifications on your blockchain applications, you can do that. The enhanced APIs that I've talked about. And we have an awesome support team. You never talk to a bot when you're using Alchemy. You always talk to real humans. So yeah, this is our product suite. The main premise of my talk was on our supernode engine, so I won't get into too much on the other tools that we offer, but happy to take questions from here. Yeah, thank you.
So, I have a question. Is it safety to create some kind of Web3 apps only with front-end and contracts? So, I put the link to the Alchemy in front-end, so the malicious actor can steal my link to the or to the Alchemy and try to use my paid node. So, what is the best practices for it?
Yeah, that's a really, really good question. I was actually just yesterday we were talking about that with a bunch of people. And so this is, just to kind of repeat the question here, one issue that Web3 applications have is that they often don't have a backend, right? The backend in Web3 applications is the blockchain itself. So in an ideal world, you have a front end, you have a smart contract, and all of those requests go to the backend, right? So you're not actually controlling or storing any data because the backend is the blockchain. Now, if you're using something like Alchemy, then your key kind of lives in that front-end application. And so his question was like, what's the best practice there? Because you have this API key that I showed you guys earlier. And if it lives in the front end, then in theory, you know, a bad actor could come and take it and use it. My short, kind of frustrating answer for you is that this is a really hard challenge to deal with when it comes to not having a back-end in Web3 applications because you can't protect it. Some solutions that we do have right now, but like really, this oddly enough doesn't come up as much as I thought it would. So like surprisingly, not enough people are doing this, but again, our platform is free, so like you could always just spin up a free key and use it. But so there's things like whitelisting. So you can do whitelisting of domains, so that only requests from your domain can go through. So if I copy your key and then I try and send a request from another application, it won't work unless your domain is whitelisted. You can do IP whitelisted. So you can only take requests from certain IPs. There's ways to do IP blacklisting too. So if you notice an IP that's sending a lot of traffic and you don't recognize it, you can blacklist that IP. There's rate limiting you can do. So you can rate limit certain keys and users so that if you see people using a lot, you can start to throttle their requests. And then they're no longer incentivized to use your key. In general, it's a bit of a tricky problem that has to do with how Web3 apps, how their stack kind of works. But it's a really good question. There are a couple solutions to it right now that exist.
Hey, how's it going? Have you been thinking about ZK AVM any in terms of like stateless, multi-chain proving so that you can serve data in a secure way? Because many of the EVMs will be compliant once they have native ZK AVM, right? So you can have Alchemy type consensus around the fact that you've recursively proven a chain and then serve up data with Merkle proofs that the data or your transaction exists in that blockchain in zero knowledge with a small, like maybe 20 kilobytes proof or something like this. What are your thoughts? Like, would that be in the consensus layer? Or would it be completely stateless? Or have you been thinking about it at all?
Yeah, that's a good question. So I'm not quite sure if I'm completely understanding what you're saying. Basically, like validating that data served is correct through like some sort of ZK proof. Is that kind of the thing?
Well, you can have a rolling recursive proof like through IVC or some other mechanism, but you can have like a system that just keeps track of the Ethereum blockchain and recursively prove it. Since native ZK VM exists now, you can recursively prove it, and then a service in a backend could be trustless and censorship resistant in terms of giving you data that you know is correct. The only thing is you don't know if the blockchain is rolled back or not. So if the blockchain is final, then you know for sure that it cannot be rolled back and you can trust it. But I wonder across multiple blockchains, multiple EVMs, some service like that, like a decentralized Infura, needs to be stood up that you can not have to trust a consensus or something like this.
Yep. Yeah, totally. No, I think that's absolutely fascinating. It's definitely something that our team talks about a ton. I think it's actually not a trivial problem to solve, which is a big reason why no one has solved it yet. And so the big need that we're hyper-focused on solving at Alchemy, at least for this moment, is making sure that like apps can scale and run and are serve consistent data. So that's kind of first and foremost. Like, how do we make sure that Web3 applications can actually like scale and exist in the nature that they want to? And then that second layer is doing stuff like this. So we've absolutely talked about it as a team and thinking about what kind of ways we can do this, especially across multi-chain, which is some of the things that you're getting at in your statement. I don't have a definitive answer for you, like yes, X, Y, and Z things, but I think it's a really, really fascinating space and something that we've talked about a ton.
Sure, thanks.
Yeah, so can you blink once if there's going to be a token airdrop and blink twice if there's not going to be a token airdrop? Or blink 3 times if, you know, yes or no, maybe something.
Yeah, I've never blinked in my life, so I can't.
I take your silence as a yes.
No, truthfully, like, there's not really an eminent need for us to have a token right now, just the way our kind of platform functions. So, and I think as a company, I don't think we're super keen on like launching a token just to launch a token. And so if and when there becomes a strong need for us to do that and build out a platform where the incentives are aligned and things make sense, then like I'm sure we would. But I don't know what to blink anymore because I forgot your rules. So I'm just not going to avoid that. Yeah, so the short answer is no, but it's not like we're strongly against tokens or anything.
No worries. Thank you so much.
First of all, I would like to appreciate the way that you express your solution. It's an amazing way. I believe that this solution represents a single point of failure because at the end it's centralized solution, isn't it? How do you guarantee that all the time your solution is running? This is question number 1. And question number 2, this URL represent to me a way to get the data from blockchain. Mm-hmm. What's the guarantee that you are not tampering the data or nobody is tampering the data?
Great question, yeah, great question. So I'll take number 2 first. So the question was like, you know, we're serving blockchain data, right? So you're reading requests from us and we're serving it back to you. So how do you guarantee that we're not tampering with that data when we do serve it back to you? And the short answer is like those incentives aren't aligned for us. Like we have absolutely zero incentive or like initiative to want to do that to you. And the reason being is because you can always, this is the nature of blockchains as they exist, you can always use something else. You don't have to use Alchemy, ever, right? If we're in Web 2, and you have these centralized servers, and I decide one day to be malicious and I shut your server down, maybe I stop feeding requests, maybe I modify data, there's no way to recover or get that data in any other way, right? Because they're on centralized servers. In Web3, if you woke up one day and you were like, you know what, I don't want to use Alchemy anymore, you absolutely could, and all of the data, the whole history of your application, and everything that's going to happen next is still there. It's on the blockchain. You can access it by running your own node, you can use another provider, you can go through your wallet, like all the data still exists and is there. So there's no real incentive for us to like modify or tamper with your data because then you'll just turn off of us and you will no longer use us, right? We don't have a product anymore or a business if we do that. So that's kind of to answer your second question. And your first question is around like centralized point of failure. And so yeah, so if you think about like kind of the beginning parts of the talk around like running a single node, data consistency, all of these issues that occur when running node infrastructure, that happens all the time with applications. And that's kind of the reason why, that is the core reason why we built this out. Is because now there isn't a singular point of failure under the hood. So, taking a step back, this is more a philosophical question of like, what is centralization, what is decentralization? And so from this perspective, we're not running a singular node, so we don't necessarily have a singular point of failure. We're running a bunch of node clients. We're running a bunch of software and consensus mechanisms above as well. So our infrastructure engine as it exists is just a lot more reliable than a traditional node infrastructure engine is.
I'm not talking about your solution is scalable, yes. I agree with you. However, at the end, it's if the infrastructure for any reason went down, the whole solution will went down. While the infrastructure is running, you have the guarantee that you will serve me. Got it?
Yeah.
So I'm thinking that if we think about, I'm not talking about that your solution is bad or not good.
No, yeah, I think I
I'm
understand
talking
your
here
question,
about an alternative scenario for, like, for example, let's imagine a serverless node.
Yep. Yeah, so, okay, I see what you're saying. I see what you're saying. Like, what if the entire thing was done? Yeah, and I think this is like so the short answer is like, look, Polygon went down for like a week and a half, 2 weeks ago. The entire Polygon chain went down. And people were like, oh, like, you know, stuff's not working on Ethereum, Alchemy, all these things. It's like, no, like, the entire Polygon chain went down. Like, shit happens, right? Like, things can just go down. So the risk is like, all right, what if Alchemy goes down? Like, how does that, you know, what can you do there? Yeah, yes. The whole idea is that failures happen, things happen, Ethereum can go down, Polygon can go down, all these things happen. We're reducing that risk. I think you're exactly kind of summarizing it in a really clean way. You know, by using stuff like this, by building kind of this higher level implications and stuff, it reduces the risk. Yeah, good question though.
Any more questions? Yeah, it seems that everyone spoken. So thank you very much for your talk. And it was really educational. Yeah, probably both of them.
Oh, one last thing. We have swag over there. Bunch of Alchemy shirts. So these shirts, this shirt, and a bunch of stickers. Yeah, so if you want swag, there's not that much of it because people like took a lot yesterday. So definitely go grab some swag if you want to.